In this section, we are going to start with understanding what is a verification plan. A verification plan is a specification document for a verification effort. It is a documentation that captures the planning that you do to execute your verification, just like any other plan that you do to get your tasks done efficiently. So it's a mechanism that will ensure that all the features are verified as needed. So basically your design spec captures all the features that are supported by the design, and the verification plan is kind of built based on the design document being referenced. Now this document should capture what has to be really verified. So it should capture all the features that the design supports, how those has to be verified, and under what conditions it has to be verified, whether to verify the features independently, whether to verify the features in a combined manner, etc. What are the stress conditions? So this document captures all the details about what has to be verified. The document or this plan also should capture how to verify all the features. Typically, it should capture details on what are the methodologies to be used. Is simulation-based verification good enough, or other areas where we can apply formal verification? What are the checking methods to be used? Should we apply coverage or not, etc. All the details are kind of captured as part of your initial plan, and then this document should capture all the details. The plan will also capture like what are the kind of stimulus that you'll be applying to get your verification done, what are the kind of checkers that you would implement, what levels of coverage that you will be implementing. The plan should also have a priority for features to be verified, especially with designs getting more and more complex and the number of features and the number of combinations increasing drastically. It's always important to capture a priority of which features are must be verified and which can kind of wait. So that's why the plan should capture all of these details, which help in executing your verification smoothly and efficiently. Now let's see like what are the kinds of approaches that we can take towards verification. There are basically three approaches. The first one is a black box approach. The black box approach towards verification is an approach where the verification engineer doesn't need to really know everything about the design implementation. He just needs to know what are the features that the design supports. So the design is treated like a black box, and then we approach verification in that way. Now there are some good things and some bad things with this approach. The good thing is that tests are independent of implementation, so you can reuse your test across different design implementation. One of the major disadvantages is that since you don't really care about understanding all the design, you will have less of visibility and observability into the design. And also with the kind of design complexities that we deal with in the current days, this is like almost impractical, and it's not like followed in most of the verification. The other approach is like a white box approach towards verification, where there is a thorough or a good understanding of the design implementation before we start the verification. The good thing is like since we understand the design implementation, there'll be full visibility and observability. So it helps to write like better stimulus or test case to cover every feature or every design implementation, and it also gives you like good observability during debugs. Now, based on how we kind of create test in this approach, the test could be tied to the specific implementation so that it might limit your reuse of the test across different projects when the implementation changes. And the third approach is a gray approach, which is kind of a compromise between both the approaches. So there are certain things which you don't really need to know everything about design, and you can go and create tests and verify, whereas like certain scenarios or features, you will need to understand the design before you thoroughly verify. So these are the three approaches that we normally use for verification. Now let's see like what are the different levels of verification that are typically performed. So if you see this diagram, it shows like how a design is kind of partitioned during the product design phase. So every design is kind of partitioned into several systems and subsystems and core IP blocks, units and subunits. And then the design starts kind of building up from a bottoms up approach, where like most of the subunits and then the units which are needed for the overall design to work kind of gets designed parallelly. And then once these design units are kind of in place, they kind of put together to form like some of the core blocks, and then those blocks are put together to form subsystems and then system on chips, and finally you get kind of a board where all your chips are kind of assembled, and that kind of forms your design. So just like how this design is partitioned, you can also have your verification partition into multiple levels. So each level of verification will be kind of suited for a specific objective. So lower levels of verification, that is typically when the design starts with like subunits and units or core IP blocks, you can do a verification of that specific unit of that or that blocks in a standalone environment. At a unit or a subunit level, you don't really need to build a proper test bench or a verification environment. You can do certain ad hoc basic operations like forcing certain input signals and then checking whether your design outputs kind of behave as per your specification. So the good thing is like the more verification that you can do at this lower level, you can kind of find most of your early bugs in parallel to the design. So that kind of saves you time. And then once the design kind of stabilizes, you can put together multiple of these blocks into a subsystem or a system, and then you can kind of do more system level verification, where the focus will be more on interactions across these units. And that levels of verification can go up all the way till product verification. So yeah, this shows like how you can kind of attack your overall verification problem by starting earlier, doing parallelly as along the design development, and then focusing on different aspects at different levels of verification. Now we'll also see like what is a verification metrics. So just verification metrics are just like any other metrics which will help us track towards like completion of a plan. So verification metrics will help us tracking towards completeness and quality of verification. So what are some of the metrics? So some of the metrics are basically the kind of measurements that we do. So especially in the verification plan, we kind of capture what are the features to be verified, how those has to be verified, what are the stimulus, etc. So we'll have like verification metrics which tracks like how many tests are being returned, how many stimulus generators are being returned, what is the pass rates, what are the failure rates, how many bugs are we kind of finding from these tests, etc. All of these kind of measurements helps us track towards the actual execution versus what we planned originally in the verification. So that's one set of metrics, and the other set of metrics are like historical trends, especially if you are doing like project after project. Uh, the metrics or trends from your past projects will help you determine like how you are trending in the current project, and that can be useful to compare your the quality or uh, quality of verification for your current project versus how it was in a previous project. It can kind of give you like a comparison across projects on how you do. Are we doing like better or are we doing like bad than the previous projects? So that's other trend, other kind set of metrics that we use. So yeah, that's what I have in this section. So we'll see more in the next section. Thank you.